Hello, teachers and everyone. Today we will talk about Chebyshev linkage. Historical background. Panafty Chebyshev was a prominent Russian mathematician who made significant contributions to number theory, approximation theory, and mechanics. In the realm of mechanical linkage, Chebyshev sought to design mechanisms that could produce straight-line motions, with inherently challenging due to the natural tendency of linkage to produce curved paths. His work laid the foundation for various approximation straight-line mechanisms, with the Chebyshev linkage being one of the most notable examples. Introduction Chebyshev linkage. The Chebyshev linkage is a type of mechanical linkage, a system of rigid bodies connected by joints to convert rotational motion into approximate straight-line motions. Named after the Russian mathematician Panafty Chebyshev, who studied such mechanisms in the 19th century. The Chebyshev linkage is celebrated for its elegant simplicity and its ability to produce near-linear motion without the use of sliding components. Type of Chebyshev linkage. There are different variants of the Chebyshev linkage, all designed to convert rotational motion into an approximate straight-line motion. The variations differ primarily in the specific linkage configurations and the type of motion they achieve. Below are some key types of Chebyshev linkage and relay mechanism inspired by Chebyshev's original design. 1. Chebyshev lambda mechanism, the most common form. 2. Parallel motion linkage, for more precise linear motions. 3. Chebyshev-Gruber linkage, for systems requiring controlled degree of freedom. 4. Plantar mechanism, for walk or robotic leg movement. 5. Chebyshev-Panafty linkage, modified for complex path approximations. Advantage of Chebyshev linkage. 1. Simple, low-maintenance design. 2. Efficient approximation of straight-line motion. 3. Cost-effective and easy to manufacture. 4. Reliable with minimal friction and wear. 5. Versatile applications across industry. 6. Energy efficient and compact. 7. No need for complex control system. The Chebyshev linkage, simplicity and efficiency make it a powerful tool in many engineering fields, offering a balance between performance and ease of implementation.
Now let's go over the component of the Chebyshev linkage mechanism and its working principle. First, the linkage consists of four key parts. Link 1 is the frame or base which remain fixed and support the entire mechanism. Link 2 is the driver. It's responsible for initiating the movement. This can either rotate or oscillate depending on the application. Link 3 is the intermediate link, which transfers the motion from link 2 to the final output. Finally, link 4 is the output link, often referred to as the crank. This link oscillates as a result of motion transfer by link 3. Next, let's take a look at how this mechanism works. The process begins when link 2 is the driver start moving, either rotating or oscillating. This movement is then passed on to link 3, which serves as the connection between the driver and the output. As a result, link 4, the output link, start to oscillate, converting the original motion into a back and forth movement. This simple yet effective mechanism is widely used to transform rotational motion into nearly straight line motion, and it particularly valuable in applications such as robotic or mechanical systems where precision is important. The Chebyshav linkage can be found in multi-leg robots, such as robots with 4 or 6 legs, especially those designed to walk on both flat and uneven surfaces. This mechanism helps robots move efficiently and conserve energy during movement. The Chebyshav linkage is designed to convert the rotational motion of the driving motor linked to into nearly straight line motion for the robot leg. This allows the robot to move forward without having to lift its leg too high. As the motor rotates, the mechanism helps the end of the leg connect to link 4, move in a straight line or near straight path, making it ideal for walking on flat surface. A key function of Chebyshav linkage in walking robot is the reduced jerking and enhance the smoothness of the leg movement, making the robot walking motion appear more natural. This mechanism helps regulate the robot step, allowing it to walk in a way that closely resembles the movement of living creatures. In the Chebyshav linkage, the rotation of the motor or driving point or link to is transformed into nearly straight line motion at the end of point link 4, similar to how a robot leg moves in cycling. The rotation of the pedal crank causes the rider leg to move in a repetitive circular motion, which converts the mechanical energy generated by the leg into the rotational movement of the bicycle wheel. In oscillating fan, the Chebyshav linkage is utilized to convert the rotational motion of the motor into oscillating motion, which refers to the back and forth movement of the fan head. This allows the airflow to be distributed the various directions evenly. The working principle of Chebyshav linkage in oscillating fan can be described as follows. Working principle of the Chebyshav linkage in oscillating fan. Conversion of motor rotation to oscillation. The oscillating fan has a motor that generates continuous rotational motion, which is transmitted to the Chebyshav linkage. This mechanism converts the motor rotation into a backward and forward motion oscillating, allowing the fan head to move smoothly from one side to the other. Smoothness of motion. The Chebyshav linkage ensures that the oscillating movement of the fan is smooth and fluid. This helps reduce vibration or jerking motion during operation, resulting in effective airflow distribution without excessive noise. Control of oscillation angle. With the design of the Chebyshav linkage, the fan can precisely control the angle of oscillation, enabling it to distribute air at desired angles such as 90 degrees or 180 degrees. Additionally, the oscillation angle can be adjusted to meet the user preference.
The team simulate motion in program SolidWorks and use command in the program to calculate motion graph, distance, velocity, and acceleration. From the image we see, it represents the graph we measure for the output link component, include displacement, velocity, and acceleration. The first graph, displacement graph. This graph showing displacement versus time. The second graph, velocity graph. This graph showing velocity versus time. The third graph, acceleration graph. This graph is showing acceleration versus time. After receiving our topic, our group conduct research on various websites to gather information. We discovered that linkage can be categorized into two types. First, lambda. Two, state line. Our group chose to focus on the lambda type and proceeds to develop it into a project. We research further on lambda, looking into the ratio of each link, their function, and their application in daily life. Next, we model the linkage in SolidWorks, creating a representation of it. We design it in a way that allow for smooth rotation without any issue. So we develop additional component to support the movement of the linkage. Once the design was complete, we move on the fabrication stage. Our team chose to use 3D printer for the production process, with assistance from our friend to create the part. Finally, we assemble everything to once form the structure we had designed. In this stage is the process of creating a mechanism. We split it in two parts, but first we have to look at variant parts and BOM. Link 1 is a link-based part. All the link is on this part. Link 3 is the shortest links used to drive various links. And link 4 is its name is output link. It's on the base as a link 3. Link 6 is the third link named transition link. It's on the link 4 and link 3. It's used to transition the rotate on link 3 to link 4. In every link had a joint between them, make the link further, that not make link conflict when it rotates. 4 hand pins are for two links that have to rotate, and the hand pin with key is for two links that don't have to rotate. The path name based in line are for connect between the linkage and acrylic sheet. The pin base is connect the path base line and the path base inline. Then we come the first stage. Design the variant parts in the SolidWorks program. For our project, we will focus on simulating the Chebyshav lambda linkage, starting by determining the ratio for each link. We will use SolidWorks to design all 4 linkages and assemble the component. Next, we will simulate the movement of the assembly to see if it's option with the Chebyshav theory. Once we confirm it, the design theory, we will begin designing the pin for the link. Since this project involves rotating parts that need to be locked in place, we design two types of pin. First, the standard pin. Second, the pin with key. Initially, our linkage encouraged some interference, so we design a base for increase the distance between the components. After simulating the movement, we will work on the base connection. The goal is to increase the distance between the pins to avoid any interference during rotation. So we design another support base for the linkage and drill hole to attach it to the last acrylic sheet. We have applied the walking motion of the robot to demonstrate its walking characteristic by creating feet that move similarly to normal walking. In the next step, we will fabricate the components using 3D printing. First, we will save all the file in STL format and then process the print the parts. Once the printing is complete, we will carefully remove the component from the base and scrap the pin section using fine sandpaper. Next, we will take the acrylic sheets we purchased and use a CNC machine to drill the necessary hole. In the third step, we will begin assembling the component. First, we will take the base link and attach into the input link. The previously matched a pin to secure the back of the assembly. Next, we will attach the output link to another section on the base link and then connect the transition link to the two previous links on the base link, executing the place a joint between them. After that, we will attach the working leg joint to the transition link, making sure the pin with key are launched properly, and then we will connect the foot to the working leg. For the base support on the acrylic sheet, we will create locking point by drilling hole in the part and using a screw to secure them through the component and the acrylic sheet, locking them in place with M5 screw and M5 stud. Finally, we will connect the base support and the linkage together by using pin to drive into both components, and then finally we will have the linkage. This image of isobomb for the Chebyshav linkage mechanic show us it had 19 parts to make the linkage, but the main part is 4. In the other is the support. After our group study the Chebyshav linkage, we gain insight into its history, type of linkage, and their application when we turn our research into the project. We develop a deeper understanding of how linkage work is. This experience shows us that the type of this linkage is present in many aspects of our life daily. Thank you.